Andrew Smith from the Open University Cisco Academy, and we're going to be covering what is probably one of the briefer topics within the CCNA SRWE Switch and Routing Wireless Essentials curriculum. So this might be a 10, no more than 15-minute video, and we will move on. So as you know, from my model, I will not talk to each slide in detail. I will talk about each slide. So in networking, in switching, we talk about ingress, what goes into a port, and egress, what exits a port. And then we have something called a CAM table, or content addressable memory, which stores what's going in, what's going out, and the MAC addresses of the devices accordingly. So this is very much a layer 2 technology. It's constantly looking at the frames, and it's looking at the MAC addresses of what's coming in on the frames. Okay, so whatever comes in gets matched and mapped on the CAM table and a MAC address table. So yeah, that becomes quite an important thing to understand in the way switches work, the way network security works, especially at layer 2 of the OSI model, and how we can have things like ARP point poisoning amongst other things. And it should never allow traffic to be forwarded out an interface it receives the traffic on. So basically, when it comes in, it shouldn't be sent back again. However, you will learn that you can actually do certain clever trunking things where, there is that router on the stick technology. You could actually set up a router port on a switch interface, but a switch port will not allow that to take place. So be understanding, a switch port won't allow it. However, if you set up routing or other trunking or other things and change the way some of the features are set up, then that is no longer true, but true in this context at layer 2. Okay, so it will always forward the frame. It will forward the frame based on the destination MAC address. So the store forward order is cut through. So bring in the whole frame, then put it on. Very reliable. Or cut through. As soon as we've just got the right part, the front part, we know where it's going, we're sending it off and we're filtering it through. So this content addressable memory CAM table is quite an important live database that is constantly updating based on the MAC addresses it learns. And if you've got a switch that is connected to another switch, it will build at the CAM table of all the devices of the switches connected to it. So you can actually have a one port that's got a lot of addresses that's learned from another switch downstream that's got a lot of devices on it accordingly. So don't assume that it's one MAC per port. It's actually can be a much larger database, because downstream that other switch will know then its individual ports and store forward or cut through accordingly. So it always has to learn the MAC addresses. It doesn't go around doing archer pings. Layer 2. It learns when it talks. So as soon as that device talks and says hello or sends out a little bit of information and does something, it will pick up the MAC address from that Ethernet frame, and then it will send it to the specified physical port if it knows the destination MAC address. However, you can also set things up to do broadcast MACs, where it can go and then send it out to any device on the system accordingly. So there is a video in the curriculum that is worth watching. It's a video of the frame forwarding taking place, and I would advise you to actually sort of watch, review and learn and study that video within the content. So I've already talked about store forward and cut through, and it is actually covered in CCNA ITN as well. But basically, store forward is take the whole frame and then pass it on. Cut through is we look at the header and then start forwarding as we're bringing the rest of it through, which is much further, but then there is always a little bit of risk around reliability. Okay. So with store forward, it's high quality error checking. It can check everything, and you've basically before it pushes it on, and it will buffer, but you need higher performance to cut through. It's in environments that require lower latency, lower delay, and that is important, especially if you're doing this for a manufacturing environment, because often we're using switching technologies to run robotic assembly plants, amongst many other things. Can then worry about switching domains and collision domains. Collisions are still possible, even though that we've got auto MDX, we've got full duplex, we've got a range of different negotiation technologies. Whilst it says that collision domains are eliminated on full duplex, we've still got the risk where there is a half duplex system operating. Because obviously full duplex, you've got two-way communication. It's going to clash with that because it's a one-way stream. Obviously, with half duplex, you've got two things doing that. Yeah, if both send at the same time, or you've got a shared link, then you've got that potential collision. A broadcast domain is at layer 3. It is a subnet or a whole network segment where there is a lot of devices within that. You can send out layer 2 broadcasts, FFFFFF, and so on, when it's looking for other devices or communicating services. And what we talk about in broadcast domains is how large do we want it to be before there is too much background noise, broadcast traffic on the network. And you will segment this accordingly. You'll segment it based on performance. So if all devices can see each other, then it's a broadcast domain. If I could do a broadcast ping on a 255.255 or send a broadcast MAC on an FFFF, and they can all see each other and reply, when is it likely to get too busy and reduce or impede performance on the network? So to solve that, we also look at the way we segment the network or break down the network based on different cabling requirements, switching requirements, port density, or frame buffers on the system. So, what did you learn? Well, you've learned ingress and egress. You've learned that there is a CAN table. You've learned store forward and cut through, and there is a lot of different switching domains and broadcast domains as well. And broadcast then crosses over into the world of subnets and routers at the same time. So this has been quite a brief presentation. I'm Andrew Smith from the Open University, and hopefully you've found this to be very useful. Do read through the content, do the quizzes, and do watch that video as well.